Welcome to this short video where we show you how to use the new Shaped Reflector antenna module in SATSOFT for making a good first estimate of your payload performance. In the tutorial, we'll design a shaped reflector for a satellite at 20 degrees east. So in SATSOFT, I first set the satellite position to 20 degrees east. In the polygons window, I have already prepared two polygons, one covering Iberia and another covering the Western Europe. I've named them 36 and 35, which will be the target gains that we wish to aim for when we design the antenna. I also want to add a third polygon over the UK, and I'll import this from an Excel sheet. I click on Table Create, change the import coordinate system to match what I have in my Excel file, name it 34, which will be my gain target, and then paste the coordinates from my Excel sheet into SATSOFT. As you see, I now have 3 polygons, and I can go to the antenna window. In the antenna window, I first change my pointing error to 0.12 degrees, which is a typical value for deployable broadcast antennas mounted on the side of the satellite. We're then ready to set up the antenna, and I do this by first selecting the antenna model as we see here, a shaped reflector. In the model properties, I can set key parameters of the antenna, such as diameter, focal length, design frequency, and more. In this tutorial, I'll use the standard geometry because we're designing an antenna for broadcast mission in Ku band with linear polarization. After setting up the antenna, we can now specify the optimization. We do this in the Beamlet and station grid dialog. Here we have a number of options where we can set for the optimization of the shape antenna. First, we will select the polygon that we wish to use for the optimization, and because we only have a single coverage, there is only one choice. We can then choose if SATSOFT should auto-position the bore side direction of the antenna toward the center of the polygon. This is usually a good choice. Following this, we have 2 other options, both related to an initial defocusing of the reflector needed for the shaping optimization. Suffice to say that this ellipse should cover the entire polygon, preferably a little bit larger. The initial ellipse can be expanded to match the coverage polygon extended by the pointing error, and it can be oversized by an additional percentage factor. We choose both, and we choose a factor of 10% here. Remember to press Generate to generate the far-field ellipse. Finally, we adjust how the far-field pattern will be computed. The resolution is the number of grid points over an angular region, the size of the wavelength divided by the antenna diameter in radians. A choice of 6 will usually give a good resolution in the far-field plot. The oversize factor determines the size of the grid over which the far-field is calculated. A factor of 1 will generate a grid that just encompasses the initial ellipse. A factor of 2 will double it, and so forth. We will use 4 in this project, as shown here, and finally hit Apply for the settings to take effect. We are then ready to set up the stations that will be used for the optimization. This dialog is very similar to the Beamlet grid dialog. We choose a triangular mesh of points, and importantly, we choose to use the polygon labels as our gain goals. The stations are created when we press Generate, and we can press OK to close the dialog. Now we can optimize the antenna pattern. First, we press the Calculate Component beam, which calculates the pattern from the defocused antenna over the initial ellipse. We then press the Calculate Composite beam button, and we will optimize the shape of the reflector to get a really contoured beam. The optimization is done with the same algorithm that we use in POS, which is recognized as the premium tool for reflector shaping. In SATSOFT, you have fewer options to design your reflector, but you'll get a very good initial estimate of how much gain you can expect for a certain region. I turn off the display of component beams, beamlets, and stations. We now look at the result, look at the composite contours, and select the targets 36, 35, and 34, as well as 30, 25, and 15 dB. I choose the P1 polarization, and I select to plot the absolute value of gain. Then I change the font size to 16. Finally, I select one of the predetermined color schemes for the contour plot. I choose to pick the orange one. I click OK, and I can see the performance of my antenna. We have the desired 36 dB over Iberia. We have above 35 over most of Western Europe, except for these two small areas. And we have 34 dB over the UK. You can now try to modify some of the parameters, such as antenna size, gain goals, location of bore site, or polygons, and see what kind of performance you may achieve for different scenarios. That's it for now. I hope this will encourage you to try the Shaped Reflector model in SATSOFT, and I thank you for watching this video.